Assalamualaikum and good day. Today, I would like to introduce the electric charge and electric field under chapter 6 in the 9th week of our semester. Maybe in the first video, I would like to introduce first in the electric charge with the Coulomb law. And then maybe the next video, I will introduce in the electric charge, right? Okay, realize or know about the electrical, we are live together with the electrical. Okay, we start with the electricity, with the electric charge and conservation. Yeah, maybe from the early know about the electric charge by using to rub the ruler, the plastic with our hair, and then we try to make the from the paper, cutting paper in small size, and then what happened, the cutting paper will moving, attract to the roller that rub into our hair or the paper, or other paper or the plastic, right? This we call the electric charge or phenomena. Because the electric charge will produce the proton in the positive charge, and then will attract the negative electron charge. So the attraction will be happen in this phenomena. That's why the cutting paper in the small size cutting paper will attract to the roller that produce the proton charge. Okay, in the static electric charge and conservation come into two types, positive and negative, just as mentioned before, like the charge repel and opposite charge attractive. So if we give in the electron of negative charge to electrical negative charge, so the one to be in repulsive. So it means the gain to each other. Also, if we give the similar positive in positive or the proton in the proton, so will be repulsive or repel the movement. But if we give in the within the negative and the positive, the attractive will occur in this phenomena. That's why the small cutting paper will attract to the roller that give the proton charge. So electric charge is conserved. The arithmetic sum of the total charge cannot change in any interaction. Correct? Okay, electric charge in the atom, we have the positive inside, and then we have the surrounding by negative charge. So we call this the surrounding electrical in a negative or neutron, in the electron charge, we call electron cloud or large, very low density negative charge. In the core, we have the nucleus, a small massive positive charge. This one in the atom size. Every atom. Okay, electric charge in the atom, polar molecule, neutron overall, but charge not evenly distributed. For example, HOH, this means H2O. So H with the positive will attract to the negative of O or oxygen. So with the two atom of hydrogen will bond into the oxygen, one oxygen. So So this one we call molecule, in the molecule. Insulator and conductor. So we separate the material by two types in the electrical properties. The first one act as an insulator, and the second one act as conductor. So what is insulator itself? Insulator is no charge flow, most other material. So the electrical cannot flow through the insulator. And then opposite to the conductor, we call charge flow freely metal. For example, metal. Yeah. Most of metal can transfer the electron. Okay. So what the conductor we can identify with an insulator and conductor by testing. If we give the electron through the object, if this object can transport the electrical, this means this material under conductor. And then another one, if we transport the electrical but cannot transport the electrical to the other object. So we conclude this material is as insulator. For example, wood, wood is considered as insulator. Also plastic, we try to get more example. Plastic also considered as insulator. Okay, in this charge, the electroscope, in the topic of the electroscope, metal object can be charged by conduction. So neutral metal rod, and then the electrode in the in the negative electron can be charged by metal object. Metal rod accurate charged by contact. So this consider can be transport in the conductor material. This one we call conduction. And then in induced charge, the electroscope, they can also be charged by induction, either while connected to ground or not. Yes, neutral metal rod can we go to the ground or not. Okay, by the conductor material, we can guide to electrical to the ground by connecting of the conductor. And then non-conductor can become charged by conduction or induction, but will experience charge separation. So non-conductor, we separate of the electrical charge within the positive proton and to a negative neutron. Okay, actually the electrical charge can be measured by using electroscope. What is the electroscope? You can see from the figure. Yes, this one created by gold leaf here inside of the circle. But inside of the circle is covered by the glass from the metal. So within the gold leaf, we can see within gold leaf here, will charge off the electrical inside there. So the electroscope can be charged either by conduction or by induction. So we just to close within the positive and negative, the electrical will be seen. Can be seen by jumping of the electrode. Yes. So the charged electrode can be used to determine the sign of a unknown charge. So if negative to negative, so the electrode cannot be charged. But if we give the two type of the electrical charge, neutron and proton, so electron and proton, so the electrical charge can be seen here. Okay, in the Coulomb laws, we have a formula to calculate the force of the electrical charge. So the electrical charge is within two point or two atom to in the atom, within the atom, within the one atom, we can conclude as Q1, and then another is Q2. So separate by distance. So the force we will give within two charges by distance. So experiments show that the electric force between two charges is proportional to the product of charge inversely proportional to distance between them. So it means if we separate by certain distance, will be effect by the force, electrical force. If the low electrical force, it means the distance will be increased. So more close to the charge will be produce the higher force of electrical charge. Okay, this one formula that we try to calculate for force occur in within the two atoms. So by F equal to K Q1 times to Q2 over 2 distance square. So K is constant, constant, and then R is distance. So Q1 is atom 1. So we produce, we can see the F will be E reverse from the distance. Yes. With the higher R, will produce smaller of force. So the force is along the connecting the charge and is attractive if the charges are opposite and repulsive if they are the same. So as I mentioned before, with the positive in the same sign, whether the positive or negative, the force will be repulsive. If with the two signs different, the force will be attractive. So what the constant K equal to almost 9. Actually, this one we can consider as 9 times 2 10 power of 9 Newton meter square per coulomb. So C is Coulomb, Coulomb law. The charge produced by rubbing or typically around the microcoulomb. So actually, the charge will produce by the in the atom level. So charge of the electron is constant. So every electron will be give 1.602 times 2 power 10 with the negative power 19 of Coulomb. C is in the unit of Coulomb. So electric charge is a quantized in the unit of the electron charge. Okay, the electron will give the unit in the coulombs. So the proportionality constant K can also be written in the term epsilon. Epsilon is mean the permittivity of free space. So in the free space, so the charge will be go from the free space. So free space, we can relate to the K formula as permittivity equal to 1 per 4. This one is pi K, because we consider in the circular condition. So we can get the permittivity of the constant is 8.85 times to 10 power negative 12 coulomb square per Newton meter square. Okay, this one is we can replaced by K. So K equals per 4 pi permittivity. So if you carry out, we derive the permittivity by using this formula. Okay, now we just introduce first the electric field before we go in deep about the electric field. So the electric field itself is defined as force a small charge divided by the magnitude of the charge. So we just divide. So can be see E with the force, is mean in the vector equal to force in the vector divided by the electrical charge, small charge. So can we see here what the meaning the electric field? So we have several force here acting in the condition of the electrical charge. So one from here, one from here. So this one considered as electrical field. Okay, electrical field, we have the certain number of force acting in certain direction. Okay, if we relate the E with the formula of force of Coulomb, we can derive the new formula. So before we go to electric charge, we already know how to derive the F, electrical charge force, and then we divide by Q. Q is electrical charge. So the final, we can simplify the electric formula, electrical field, as K times to Q over to distance square, right? So if we derive the K relate to the permittivity, free space, we can use this formula. If we have number of permittivity, we can use this formula. Okay, this one is single point charge. For Q1, for example, Q1, if we try to calculate electric field in the Q1, so by Q1, if we have the other number of Q, we can use the next Q. Okay, force of point charge in the electric field. So if we refer to formula, force of electrical charge equal to Q times to the electrical field, it means F and the electrical field is opposite way. It means F equal negative to electrical field. So opposite way. If the electric Q in the negative, this one negative, so electrical field will opposite. If Q in positive is similar way or similar direction with the electrical field. So please refer to the formula condition. So Q sign will be influenced in the direction of the electrical field and the electrical force. Okay, the end of this video, you should be got some idea in the how to draw diagram, show or charge with the sign, electric field, and force with the direction, and then how to calculate force using Coulomb's law, yeah, add forces vectorially to get results, and then you can check your answer, true or false, yeah, based on this video. So I hope we can see you again in the further video in the electrical field, yeah? Electrical field. Okay, that's all in the first video in the electrical in chapter 6.